Good afternoon. Again, we'll start from the where we have left in the previous lecture. Yeah, Professor Dr. Sanjay Popal here. We are going to talk about the oxide ceramic properties. Till now we have seen what is the oxide ceramic, what are their types. Okay. Now, if you see in general, the properties of the oxide ceramics are listed here. They are having high hardness and wear resistance, low ductility, high compressive strength, whatever we have discussed in the previous slide. High melting point, good thermal stability. That means they are not going to change their properties due to the application of temperature or due to the high temperature working atmosphere. They also have a low thermal expansion. That means due to the effect of heat, they are not going to expand, or their dimensional stability is going to be maintained. Then excellent electrical insulators except under some extreme conditions, and high resistance to oxidation and corrosion, inert in most of the acidic and alkaline environments. So on this you may have a question that just write down the general properties of oxide ceramics. After that, these are some applications of the oxide ceramics. In electronics, we can have insulators, substrates for the integrated circuits, and some capacitors. We can use this ceramic material as a capacitor or insulator in case of electronics application. In biomedical applications, we can use them in a dental application. In hip implants as well, alumina and zirconia can be used to just replace your hip and all that. So that also can be done with this one. As far as industrial applications are concerned, they are used for cutting tools. They can be used for bearings and wear resistant linings. Aerospace and energy applications, thermal barrier and fuel cells. Solid oxide fuel cell using YSZ, Yatri stabilized zirconia, and some optical applications like laser hots like YAG, yttrium, aluminum garnet, or some optical fibers also can. So these are some general applications of the oxide ceramics. And here are some. Now the next type is insulators, ceramic insulators. मैं जो बात कर रहा था previous lecture में, I am talking about this particular object which you will find on the high voltage carrying wires or poles. Okay. These are non-metallic inorganic materials that resist the flow of electricity. Insulator का मतलब क्या है? What do you mean by insulator? They will have very high resistance to the flow of electricity. Okay, so that is why it is in case of this electric, we can also call them as electric insulators. Thermal insulation का example, can anybody tell me? Your thermos is a kind of insulator. If you keep a water, whether in a hot and cold condition, it will remain for a long time in the same condition. That means whatever the material used outside that particular thermos bottle, that can be used as an insulator material. They are widely used in electrical systems to isolate electrical conductors without allowing current to pass through them. So whatever the wire is also kept on that particular insulator, and that is installed on that mild steel or whatever the steel pole is there, on that it is going to be installed. So for that purpose, these insulators or oxide insulators, ceramic insulators can be used. There are some types. I have just here taken the tables. Some ceramic insulator types are pin type, suspension type, strain insulator, post insulator, bushings are also there. Their description and their use case is also given. So for pin type, you can see that it is a single ceramic unit mounted on a pin, and it is used for power distribution lines. In suspension type, it is a disc-shaped unit linked together. It is used in high voltage transmission lines. I am talking about these shapes. What are the shapes? Here we have seen this kind of disc shape and all that. Okay. So here pin type means simply a kind of a pin which is mounted. A kind of a pin like somewhere here the pin is going to be likely which is going to be mounted. Okay. single ceramic unit mounted on a pin. Then suspension type disc-shaped unit linked together. Then strain insulator used in tension lines. That means you might have seen that towers, electricity towers in the rural areas, and these insulators are hanging like this. कौन से इधर आता है एक इधर ये साइड में आएगा एक दूसरा ये साइड में आएगा. Okay, that is again insulating material kind of. No, it is not that. But it is used in tension lines. मतलब जो towers देखते हैं हम बड़े-बड़े, उसमें जो ऐसे जब दूर-दूर तक लाइन अगर कनेक्ट करनी है, बड़ी-बड़ी लाइन्स वायर्स होती है वो, उसको अगर कनेक्ट करने हैं तो वो टावर से ऐसा हैंगिंग रहता है वो इंसुलेटिंग मटेरियल. I hope you guys are able to imagine. Okay? So that is a kind of tension lines, supporting mechanical loads. Then post insulators, cylindrical shape, support conductors. These are used in switch gears and substations. Then bushings are there, insulate conductor types, conductor entry points, transformers and circuit breakers. In this you can have this kind of ceramic insulator material. What are the materials used for the ceramic insulators? The material propylene is there, kaolin plus quartz plus feldspar. Then statite is there, magnesium silicate, then alumina is also there, and then corderite is also there for the material to manufacture the ceramic insulators. So these are the materials from which we can manufacture the ceramic insulators. Their properties also given and their uses also given. If you say for propylene, strong, weather resistant and good insulator. Statite, it is good dielectric strength and low losses. Alumina, high thermal and electrical resistance, and corderite is low thermal expansion and good insulation. So their applications are also given. I am not going to ask such a detailed question because again it seems difficult to remember and all that. So okay, but you should know what types of ceramic insulators are there and what are the materials which can be used to manufacture the ceramic insulators. That you should know about that particular materials. Then you can have these properties of the ceramic insulators: high electrical resistivity, excellent thermal stability, resistance to the moisture and chemical attack, mechanical strength is also going to be maintained, excellent insulation performance, durable and weather resistant, long service life and environmentally stable. I think all the points you can understand. There is no need of extra explanation on this. By reading this one, you can able to understand what kind of application is this. And here you can see the power. I am talking about this one, and I am also talking about this insulating material. Okay. Or here again, this is also insulating material. Okay, where you can, in trains, electric wires are going to be there. Here you can find the applications of transistors and all that. Power transmission and the application of ceramic insulators are listed here. In power transmission and distribution lines, transformer and circuit breakers, electric trains and railway electrification, and electronics such as capacitor, resistor, RF components like this, and for high temperature furnaces where insulation is important. Because here you can see that inside this furnace heat is there, or we have used our furnace in the lab as well. You will feel heat only when you open the door, otherwise you will not feel the heat. So that asbestos material is going to be used used as an insulator material. The heat is not going to be conducted to the surrounding atmosphere. Okay? So that is the high temperature applications furnaces. Okay, so here you can see that I may have a question like that. Define insulators. Give their properties and applications. Because here I am not going to ask any question, material used and ceramic insulator types. But also here if you want to have a question, what are the different types of ceramic insulators? Give their one-line description and use. What are the different types of ceramic insulators? Give their one-line description and use. What are the different materials which are used to manufacture ceramic insulators? Give their properties and uses. This kind of question, if there may be question on this, like this kind of question may be asked. Then if you have general question that define ceramic insulators, their properties and applications. Okay? Then the next topic is bioceramic materials. Ceramics के बारे में हमने कितना देखा, दूसरा पहला टाइप ऑक्साइड ceramics हमने देखा. We have seen oxide ceramics. It's different types of oxide ceramics, their properties and uses. In the last one we have seen ceramic insulators. Again, their properties and applications and different types of ceramic insulators. And now the bioceramics materials are there. These are the materials which are used to replace the human parts damaged due to any kind of accident or something like that. So here you can see that the basic requirement of a material when you are going to use it to replace your body part, that the material should be biocompatible. What do you mean by biocompatibility? That means your body tissue should accept that material as a body part. And previously we have already discussed that now in real world now, I think in the entire world there are some 8 to 10 people are there, those are living now on artificial heart. Their heart has been, total heart has been replaced by the materials like biomaterials. So basic requirement of the or basic property of the biomaterial or the material which we are using as a biomaterial, it should be biocompatible. That means our body tissue should accept that particular material. There should not be any kind of corrosion, there should not be any type of erosion into the body, otherwise it will again become septic and you have to have more operations and all that. Nowadays, some smart materials are coming into the picture. Previously, if the accident happens, for example, unfortunately किसी के पैर में रॉड वगैरह डालना पड़ता है, तो वो रॉड 1 साल या 2 साल के बाद वापस निकालना पड़ता है. But nowadays, some of the materials, smart materials are there, which the body actually consumes that material over the period of time. मतलब एक बार आपने वो मटेरियल का रॉड डाला तो उसको निकालने के लिए बाद में आपको वापस हॉस्पिटल में जाने की जरूरत नहीं है. Body can absorb that material over the period of time, and your bone or whatever the fracture part is there, that is also going to be repaired. Okay. So that kind of biocompatibility should be there in the material if we are using that material for replacing our body parts or replacing our any injured part due to the accident and all that. So bioceramics are the ceramic material used in medical and dental applications. They are designed to interact with the biological system, that means biocompatibility, and can either support, repair or replace damaged tissue in the body. So here you can see that we can have some joints, we can have some teeth all the way. This is the example again. Again you can have some knuckle joints or hip joint also, hip joints as well. मराठी में हम कोबा बोलते हैं, कोबा बोलते हैं मात्रा में से जनरली हा जो बॉल आहे इथला that ball is going to be replaced. Okay. So this kind of applications you will find in case of bioceramic materials. Their classification you can see: bio-inert, bioactive, and bioresourceable. Bio-inert means alumina, zirconia, titanium, carbon, and nitride-based ceramics are there. Bioactive means glass ceramics, calcium phosphate, and hydroxyapatite (HAP). And some bioresourceable are calcium sulfate and others. Now what this bio-inert means, material when placed in the human body has minimal interaction with the tissue. That means they are not going to react with the body tissue, that's why the name bio-inert. Then bioactive means material which placed with the human body, when placed with the human body, interact with the surrounding bones and soft tissues. And the last one is material which placed within the human body start to dissolve and slowly replace the advanced tissue. That's why I am talking about this kind of material where nowadays you don't have a need to remove that rod once you place inside that particular damaged part. Okay. So common materials are alumina, zirconia, hydroxyapatite, then bioglass, and then tricalcium phosphate. These are the materials. Again, one-line properties and use is given. Hard wear resistance used in joint replacement. Zirconia strong and tough, used in dental crowns and implants. Hydroxyapatite similar to the bone, used for bone repair and coating. Bioglass, bonds to bone and tissues, used in bone fillers. And tricalcium phosphate, resourceable, used in bone generation. So in one line I can have the question that what are the different bioceramics, give their applications. List out the different types of bioceramic materials and give their one application each. 5 materials are there, we can have 5 marks or 6 marks, 5 marks or 6 marks question on this. Properties and applications of the bioceramics are given. Biocompatibility, as I told you, safe for the body. Bioactivity can bond with the tissues, some types. Then mechanical strength varies based on the material. Chemical stability, resistant to body fluids, and porosity promotes cell growth in some implants. Application: orthopedic, dental, spinal and cranial repair, tissue engineering, scaffolds, and bone regeneration materials. So about the bioceramics, only 3 slides are there. Definition, different types of bioceramic material, their properties. In 1 or 2 words I have just listed out the properties and 1 or 2 applications of the same. And here again key properties of the bioceramic materials and their common applications or general applications like orthopedic, dental, spinal, cranial, the tissue engineering, scaffolds and bone regeneration materials. And the last type is again the glasses. What do you mean by glass? I think you have studied this somewhere in 12th or 11th or 12th or in first year chemistry. Chemistry. Huh? Have you heard this word before? Or have you learned about the glasses before this? Okay. A state of matter as well as a type of ceramics. Glass is a kind of state of matter and it is also a kind of ceramic. As a state of matter, the term refers to an amorphous, non-crystalline structure of solid material. Glass is a non-crystalline or amorphous material of solid structure of solid material. And the glassy state occurs when insufficient time is allowed during cooling from molten state to form a crystalline structure. When the glassy step is going to be achieved, when you are not allowing or when you are not giving that much of time for the cooling process. That means you may have a fast cooling or something like that before reaching to the solid crystalline structure. So in between whatever the structure you are going to get, that is nothing but the glassy structure. As a type of ceramic, glass is an inorganic, non-metallic compound that cools to the rigid condition without crystallizing. That means without having crystallization in that particular process, it will cool to the solid and it looks like a glass. Silica is the main component in the glass product, usually comprising 50 to 75% of total chemistry. Glass का अगर chemical composition अगर हम देखते हैं, so you will find silica, that is SiO2, around 50 to 75% in the composition. Then it naturally transforms into glass state upon cooling from the liquid, whereas most of the ceramic crystalline upon solidification. So these are some definitions of glasses. Then here ingredients and their role. What are the different ingredients in the glass material and their role? Sodium oxide, calcium oxide, aluminum oxide, magnesium oxide, potassium oxide, lead and boron oxides. What is the role? Act as a flux or promoting fusion during the heating. When we are using these materials as an ingredient, so during heating of the glass material, if you add them, they will act as a binding material or fusion material. Okay, during heating. Before reaching to the solid crystalline structure. So in between whatever the structure you are going to get, that is nothing but the glassy structure. As a type of ceramic, glass is an inorganic, non-metallic compound that cools to the rigid condition without crystallizing. That means without having crystallization in that particular process, it will cool to the solid and it looks like a glass. Silica is the main component in the glass product, usually comprising 50 to 75% of total chemistry. Glass का अगर chemical composition अगर हम देखते हैं, so you will find silica, that is SiO2, around 50 to 75% in the composition. Then it naturally transforms into glass state upon cooling from the liquid, whereas most of the ceramic crystalline upon solidification. So these are some definitions of classes. Then here ingredients and their role. What are the different ingredients in the glass material and their role? Sodium oxide, calcium oxide, aluminum oxide, magnesium oxide, potassium oxide, lead and boron oxides. What is the role? Act as a flux or promoting fusion during the heating. When we are using these materials as an ingredient, so during heating of the glass material, if you add them, they will act as a binding material or fusion material. Okay, during heating. Increases the fluidity in the molten glass for processing. If you want to have different shapes of the glass materials, nowadays you will have that sunroof and all that in the bikes, or some door panels and all that. How they are going to be made up of? They are going to be made up of by this kind of a casting process, even glass casting you can call it as. So these ingredients are added so that they will act as a fusing material or flux material, binding material. They will also act as to increase the fluidity of the material. That's why you will find the different shapes, different molds are there into that. Every cavity of that particular mold should be filled by the glass so that it will have the different shapes. So for that purpose, fluidity of the glass is required. Then improve chemical resistance against the attack by acid, basic substances or water. अभी आप कोई भी vehicle का कांच अगर टूटी हुई देखते हो, you will find that glass of the vehicle is not going to damage you. It will just break into the crystals, small crystals, and they are harmful. They are not harmful as much. Okay, थोड़ा injury तो हो सकता है, but it is not as like a pure glass. Okay, so it is made up of crystalline. Why it is made like that? Because this kind of ingredients are there. Then there will be no effect of any acid. There will be no effect of any basic substances or water or any chemical effect on that particular glass because ingredients are there. They will also add color to the glasses. We can see different types of colors. Big IT buildings are there, IT sectors are there. You will find that bluish glasses in the buildings and all that. Okay, so different colors we can add to the glass and alter the index of refraction for optics. What do you mean by refractive index?
Ratio of speed of light in the given material with respect to the speed of radiation.
Ratio of speed of light in the given material to the speed of light in air. Okay. Where we have used this concept in lab, metallurgy lab, whether we have used this? To find out the numerical aperture of an objective. What is numerical aperture of an objective? It is light gathering capacity of an objective. So if there is an air in between the surface from where the light is reflecting back, so air is having refractive index 1, isn't it? Air is having refractive index 1. So that whatever the light rays which are reflecting back from the surface of the object, if there is air in between the objective and the surface of the surface, then all the rays are going to be collected back by the objective. But if there is any water in between the objective lens and the surface, the refractive index is different. I don't know exactly the refractive index of water, but it may be less than 1, isn't it? So it will be less than 1. So what happens? That reflected rays may go beyond the scope of that particular objective, and objective may not absorb or may not collect all the reflected rays from the surface of the specimen. So that is refractive index. So here they will also alter the index of refraction for the optic means. Well, if these glasses are used for making spectacles and all that, refractive index may be different, or that contact lenses and all that. In that case, we can alter the refractive index and we can have that or use of this particular glass for the particular application. So that is one of the application. So here various ingredients are there and the role is listed. So list out the question might be list out the ingredients of glass and their role. Applications you can see window glasses, containers, cup jars, bottles, light bulbs, laboratory glassware, flask beakers, glass tubing, Glass fiber insulation and fiber optics, and optical glasses are nothing but the lenses. Colored lenses, यहाँ पे जो color के बारे में उन्होंने जिक्र किया है, add color. You may have some colored lenses. Okay, you may have seen celebrities or any horror movie or something like that. Whatever the horror eyes you will see, that are just made by the lenses. Different types of color lenses. एकदम असं एकदम पांढरे शुभ्र डोळे वगैरे ते कसं तयार होतं. Okay, so that kind of lenses are going to be used for making that particular color effect. And here are some glasses ceramics. A ceramic material produced by conversion of glass into a polycrystalline structure through the heat treatment. The definition of glass ceramic is given in the first point. It is a ceramic material which is produced by conversion of glass into a polycrystalline structure through heat treatment. Ceramic नाम है ना तो उसमें heat आएगा. Okay? So due to the heat treatment, whatever the ceramic material is there, it will be converted into glass or into a polycrystalline material. That is nothing but again through the heat treatment. Proportion of crystalline phase range from 90 to 98%, and remainder may be a can material, because we are adding these binders, we are adding this ingredient in the glass. Okay, so if you see the crystalline part, 90 to 98% crystalline part will be there inside that particular glass ceramic, and the remainder will be 2% impurity. You can call it as, or you can call it as a gang material, or any kind of other entrapped impurity during the solidification of that particular gas. So that is one of the proportion, or how much crystallinity should be there in the glass. That is given over here. About 90 to 98% crystalline structure will be there, and about 2 to 10% might be the gang material. Grain size significantly smaller than the conventional ceramics, which makes glass ceramics much stronger than the glass from which they are made. जो ग्लास से हम उसे बना रहे हैं उससे ज़्यादा स्ट्रॉन्ग बन सकता है. कैसे? We are making the crystalline size a little bit, or we are reducing the size of the crystal. So due to reduction in the size of the crystal, strength increases. Again, same funda we can apply. What we have learned in case of metals, a fine grain material will be more stronger, tougher than the porous grain material. So same fundamentals can be applied for crystalline material as well. Grain size significantly smaller than the conventional ceramic, which makes glass ceramics more stronger than the glasses from which it is produced. So due to crystal structure, glass ceramics are opaque, not clear. Opaque means what? Usually grey or white. Opaque means not fully transparent. Okay? There is some insufficient transparency may be there. So that's why they are opaque in nature, usually grey or white, and not clear. If you see the application of glass ceramics, you will find the applications in cooking ware, that is corning ware, heat exchangers and missile radomes. So here you can see this kind of glass ceramics. So this can be used for high strength application in aesthetic low cost. जो building के कांच है, that can be made from this one. That construction में हम कांच का glass ceramic का use कर सकते हैं. Then we can have the kitchenware में appealing aesthetic to low CTE. Then we can have it is in electronic applications like high ion conductivity, chemical stability and good formability. We can have in medical applications like high strength, appealing aesthetic, bioactive, and we can have in military applications as well high thermal stability, high radar wave transference and low CTE. Okay? So these are some applications, and optical applications as well. Construction, kitchenware, electronic, medical, military and optical applications.